This problem requires that we add 5,008, 24, and 791. So we are going to add the numbers together. Write down the first number. That's 5,008. Of course, the place values are added that we might be able to have a good understanding of the place values of the numbers. So we have the place values of the numbers written above them right there. Next, write 24. We're going to write 24 by placing the ones digit below the ones digit. Then we are going to place the tens digit in its respective place under the tens digit. Next, we are going to write 791. And of course, we're going to place the ones digit under the ones digit. That's what we're going to do first. So we place that ones digit right there in its own column and place the tens digit under the tens digit. Place the hundreds digit under the hundreds digit. Now that we have the numbers correctly written and aligned in the proper way, we are going to add the numbers. So let us add the numbers. We are going to add beginning in the ones column. So add the numbers in the ones column first. What are the numbers in the one column? Those numbers are highlighted there with this blue rectangle. So we are sure that those numbers are 8, 4, and 1. 8 plus 4 plus 1 is equal to 13. So Jerry, what do? Do we put 13? The instruction says, write the 3 in the ones column and carry the 1 to the tens column. There. Now we are going to add the numbers in the tens column. Next, add the numbers in the tens column. And they are all highlighted with that red rectangle. As a matter of fact, the one that we just carried from the ones column is also added. So 1 plus 0 plus 9 plus 2 is equal to 12. So write down the 2 and carry the 1 to the hundreds column. Next, add the numbers in the hundreds column. They are 1, 0, and 7. When we add them, the result is 8. There is no 1 to carry, or a 2, so there is no number to carry. So we'll just write down 8 right there. Finally, there is only one digit in the thousands column, and it is written down also. It's the 5, and the 5 is written down also. The answer is therefore 5,823, and our choice is D. How many odd numbers are there between 8 and 18? Write down all the counting numbers between 8 and 18, but what are we going to do first? We're going to use a strategy to get that done. So write the numbers 8 and 18. There we have them. And what are we going to do now? Next, write down all the numbers between 8 and 18. The question is asking how many odd numbers are there between 8 and 18. Examine all of the numbers that are between. So those are all the numbers that are between. The odd numbers are those that are not divisible by 2. They are the ones that end with 1, 3, 5, 7, or 9. How many of them do we have? There are 5 of them, and the answer is therefore option B. Of course, we may count them. 1, 2, 3, 4, 5. What is? I'm not going to call that. I did this in practice paper 2, something like this, and I did not call the number in words. But whatever this figure is, let's see how we may write that down in words. So let us first indicate the place value of each digit. And of course, we know that we have ones, then tens, hundreds, thousands, tens of thousands, hundreds of thousands. We will begin at the digit with the largest place value. It is the 5, and it is in the hundred of thousands place. So that is our 5, and it is 500,000. The next 2 digits are zeros, so we go straight to the 2, and that 2 represents hundreds. So 200. There's another 0, so we go to the final digit, which represents 8 ones and 8. So the number is 500,208. The answer is option C. What numeral has 3 in the thousandth place? Let us draw a template that includes the thousandth place. So there's our template. And of course, we have the place value of the prospective digits written right there. So we have ones, tenths, hundredths, thousandths. The thousandth place is the 3rd position to the right of the decimal point. There's your decimal point. So 1, 2, 3. So if we have one of our numbers that we have there has a 3 in the 3rd decimal place, then that is going to be our answer. So right there. So the numeral with 3 in that position is 0.303, and that is represented by option C. What elements are in the union of M and N? The elements in the union of M and N are all of the elements in the 2 sets combined. In the Venn diagram, there is no element outside of the sets M and N. So we can see that there is no element outside of the union of the 2 sets. So notice that all the elements that we have are therefore in the sets M and N. So in the Venn diagram, there is no element outside of the sets M and N. Therefore, all of the elements in the Venn diagram are in the union of the 2 sets. Which of the options shows all of the elements in the Venn diagram? So that option that shows all the elements in the Venn diagram will be correct. Options B and D are obviously incorrect. They have too few elements. Option C does not contain the elements 6 and 8. That option is also incorrect. Option A contains all of the elements in the Venn diagram. It is therefore correct. What elements are common to M and N? To determine elements common to M and N, we may look at the region where the two sets overlap. Notice this is our set M going like that, and our set N is going like that. The elements that they have in common is going to be in this region, known as the intersection of the two sets. The elements in this region are 6 and 8. These represent option D. What is 156.309 to the nearest tenth? So let us first indicate the place value of each digit. Of course, we have the place values right there, and we are going to be writing to the nearest tenths. So this is the digit that we are concerned with for now. So locate the digit in the 10th place. That's our digit. In order to write it to the nearest tenth, we need to consider the digit that is next in order of significance. That is the one to the right. Now, if that digit is greater than or equal to 5, we are going to add 1 to the 3. But that digit is a 0. The value is less than 5. We therefore do not add 1 to the 3. So we write the 3 as it is. And of course, the digits on the right are not affected and return as they are. And of course, the digits to the left are not affected and return as they are. The option is C. What is 3,216 divided by 8? So let us first attempt to divide 8 into 3. We cannot, but we do not write a 0 because it is not necessary to use a 0 to begin a number unless it is a decimal fraction. So if we are beginning a decimal fraction, we may write 0 point, and then we may begin by saying 0 or writing a 0 after the decimal point. But because we do not have a decimal point and we are dealing specifically with whole numbers at this point, we do not need to write the 0 down. We next say 8 into 32. So 8 can be divided into 32 4 times, and we place that 4 above the second digit. See, we are saying 8 into 32. The answer goes right over the 2 right there. We will attempt to divide 8 into 1 right here. 8 into 1. We cannot. So this time a 0 is placed vertically above the 1 in order to show that the 1 cannot be divided by 8. And of course, that 0 is necessary as a placeholder. We then divide 8 into 16, and that goes 2 times. So we will write that 2 down. The answer is 402, and that is represented by option A. What is 2% written as a decimal? 2% means 2 out of 100, 2 hundredths, or 2 divided by 100. When dividing 2 by 100, we desire to decrease its value by 2 places of decimal. So we need to be able to identify a decimal point. Where is it? In all whole numbers, the point is assumed to be to the right. So we are going to place our decimal point right there. So let us now reduce the number by 2 decimal places. The new relative position of the point will be 2 places to the left. We have only 1 digit to the left of the point, so a 0 will have to be included in order to complete the 2 decimal places. One, 2. We may write a 0 to the left of the point. It is not a complete necessity, but it does make our intentions clearer than if we did not have it at all. The answer is 0.02, and this represents option C. What is 3.56 multiplied by 1,000? When multiplying by 1,000, we desire to increase its value by 3 places of decimal. There we have 3.56. We desire to increase its value by 3 places of decimal. So let us now increase the number by 3 decimal places. The new relative position of the point will be 3 places to the right. We have only 2 digits to the right of the point, so a 0 will have to be included in order to complete 3 decimal places. The answer is 3,560, and this is represented by option B. What is 5/8 expressed as a decimal? The fraction 5/8 means 5 out of 8. Numerically, it also means 5 divided by 8. And we are going to divide 8 into 5, and we are going to do that long division style. 8 cannot divide into 5, so we place a 0 over the 5. And we are going to follow that by a point, and the next result will be 8 into 50. So 8 into 5, we cannot. We place that 0 above the 5. We then put the point. Then we are going to say 8 into 50. 8 into 50 requires that we know our multiplication tables quite well. So we say then 8 into 50 goes 6 times. And of course, in long division, we are going to say 6 multiplied by 8, and that's equal to 48. So we are going to subtract that 48 from 50, and the result is 2. We then say 8 into 2, and of course we cannot, but we do not need to put another point, because since we have put that point there earlier on, it means that we are continuing in our decimal places. So we put our 0 and we say 8 into 20. 8 into 20 goes 2 times. So we say 2 multiplied by 8, and that gives 16. So we are going to say 20 minus 16, and the result is 4. Again, we say 8 into 4. We cannot, and of course we are going to apply another 0. Finally, we say 8 into 40, and that's 5 times. And of course, 8 times 5 is equal to 40, so by subtracting, the result is 0, and we would have finished our exercise. The answer is option C. What is the reciprocal of 1 and 3/4? To find the reciprocal of a fraction, we need to interchange the denominator and the numerator. The figure given is a mixed number, so we need to express it as an improper fraction. So in our mixed number, we have our whole number, we have our numerator, and we have our denominator. So we are going to first multiply the denominator by the whole number, then add the result to the numerator. So let's see what we have done. 4 multiplied by 1 is equal to 4. Then we say 4 plus 3 is equal to 7. So 4 multiplied by 1 is 4. Then we add 3, and that gives 7. So the result is the numerator, which is 7, is the numerator of the improper fraction. The denominator is the same as the one that we have started with. We may now reciprocate the fraction. That's all there is to it. And Jerry Lewis is smiling because I figured that Jerry Lewis could not interchange the numbers as we have done on the computer, but Jerry Lewis cut out some numbers on a piece of paper, and he can do his reciprocal by just shuffling the numbers around. And I give Jerry 100% for imitating what we call technology. The answer represents 4/7, and this is option A. Which group of fractions is arranged in ascending order? The feature of the problem that makes it simple is the constant value of the numerator in each option. Notice that in the option, all the numerators are the same, all are the same here, all are the same there, and also for option D, the numerators are equal. Because the numerators are equal, it is the denominator that is going to determine whether the fractions are increasing or decreasing in value. For option A, all numerators are equal. The relative sizes of the fractions are therefore dependent on the denominator. The denominators are increasing. Notice that we say 4, 5, 6, 7. So the denominators are increasing. If we are dividing by a larger number, the answers will be smaller. So we are increasing the number that we are dividing by, so the result is getting smaller each time. Of course, the question says which group of fraction is arranged in ascending order. That means which group of fractions is increasing all the time. These numbers in the denominators are increasing all the time, so we are sure that we are dividing by a larger number all the time, so the result is smaller all the time. Option A is incorrect. All numerators are equal also in option B. The denominator is descending, so notice that our denominators are getting smaller each time. So because we are decreasing, we are dividing by a smaller number each time. So if we are dividing by a smaller number, the result is getting larger all the time. Option B is correct because the fractions will be increasing all the time. Although the numerators are equal in option C, the denominator decreases, then increases. Notice that it goes from 3 to 4, then it goes back 4, 5. So we do not have the values of the fraction increasing or decreasing all the time. Since the denominators decrease and then increase, we are sure that we are not having a constant decrease or a constant increase. Option C is therefore incorrect. Option D is similar to option A. All of the numerators are the same, and at the same time we are dividing all the time by a greater number. Therefore, if we are dividing by a greater number all the time, the value will be decreasing all the time. So option D is not correct. How many 2/3 are in 4? The question is similar to asking how many 5s are in 100. If a question is asked like that, what are we going to do? In answering this question, we may divide 100 by 5. So in that same manner, we may therefore divide 4 by 2/3. So let us do that. 4 may be written as a fraction as 4 over 1. So we are saying 4 over 1 divided by 2 over 3. Remember, dividing by a fraction is equivalent to multiplying by its reciprocal. So we have 4 over 1 divided by 2 over 3. We therefore multiply and we reciprocate the divisor. This one is the divisor, so that is the one that we are going to invert, and the sign that we have here should be changed to multiplication. Reduce the fraction by the common factor of 2. So notice that 2 can go into 2 and 2 can go into 4. The answer is 2 over 1 multiplied by 3 over 1. So that turns out to be 6 over 1, and that option is A. The answer is 6, and this represents option A. How would you find the product of 5, 8, and 10? Option A is incorrect. When we minus or subtract, the result is called the difference. Option B is also incorrect. The result of addition is called the sum. The result that we get during division is called a quotient. This eliminates option C. The result that we get during multiplication is called a product. Option D is correct. So the product of 5, 8, and 10 may be found by multiplying the three numbers. And that is represented by option D. M is a set of odd numbers and N is a set of even numbers. What is the intersection of M and N? The intersection of the sets is a set that contains the elements that are common to both. What do we mean common? The elements that are present in both sets. So let us write down the sets of odd numbers and even numbers. So here we have them. Odd numbers are 1, 3, 5, 7, 9, continues like that, so 11, 13, and so on. And even numbers will be the set that contains 2, 4, 6, 8, 10, on and on to 12, 14, 16. The intersection of the sets will be the set that contains the elements that we can find in both sets. That is, the elements that are common to both. By our inspection, there is no element that is in the set of odd numbers that is in the set of even numbers. The intersection will therefore contain no element. The set that contains no element is called the null or empty set. It is represented by the common Greek letter phi, and of course we have phi right there, or by the set that contains no element, which is this one that we have right there. The correct answer is option C. It is a set that contains no element. Which operation will give a quotient? Quotient? Option A is incorrect. When we minus or subtract, the result is called the difference. The result that we get during division, as we can see in B, is called a quotient. Option B is correct. So the result of division is a quotient, and we will want the operation that will give a quotient. Option B is correct. Option C is also incorrect. The result of addition is called the sum. And finally, the result that we get during multiplication is called a product. Option D is also incorrect. What is 5.5 kilogram minus 2.09 kilogram? When subtracting the numbers, the points must be placed under each other. Write down 5.5. Write down the 2.09 with the point under the point. There is our subtraction sign. Use a place holding 0 in 5.5 to complete a second decimal place, as we have in 2.09. So a 0 is going to be placed right there so that we can have two places of decimal, as we have present in 2.09. We cannot take 9 from 0, so we rename the digit that is to the right. So the digit to the right of the 0 is 5. So we rename this 5 because 9 cannot be subtracted from 0. So when we rename it, 4 is there, and the one that is from here is 110. So when we have it in the ones column, it is going to be a 10. And we are going to say then 10 minus 9 is equal to 1. Then 0 from 4, or 4 minus 0 is equal to 4. And Jerry is sticking me on my side now saying, don't forget the decimal point. Thank you, Jerry. So place the point under the point. 5 minus 2 is equal to 3, and that is the last subtraction that we have. And there is our answer. The answer is 3.41 kilogram, and this is option D. Which prefix means 100th of? The table will show all the common prefixes and their meaning. Pick the correct answer from the table. So there is our table with kilo, hecto, deca, deci, centi, milli. And kilo means 1,000 times. Remember that they were saying year 2K, year 2K9 now, right? And the last year, year 2K8. That is because the K is for kilo. So 2K means 2,000. So 2008. That's what 2K8 means. Then we have, of course, hecto 100 times, deca 10 times, deci 1/10 of, centi 100th of, and milli 1,000th of. So centi, that's our culprit. 100th of. The answer is centi, and it is option B. Question number 20. 37 marbles were to be shared among 5 children. In order that each will get the same number of marbles, another 3 were added to the total. Which calculation will give the number each received? So let us attempt to answer the question by examining statement by statement. 37 marbles were to be shared among 5 children. So write down the number of marbles. Does that make sense, Jerry? Of course it does. Write them down, 37. Then highlight another statement. Another 3 were added to the total. Add another 3 to the number. Which calculation will give the number each received? Each one will get a fraction of the total. Normally, a fraction is an expression that depicts that the numerator is being divided by the denominator. We therefore divide by the number of children, and the number of children is 5. So now we divide by 5. The brackets are included in order to demonstrate that the total is being divided by 5. The answer is therefore option B. When solving mathematical problems, the words that are used may give us clues. The word each is usually included in problems in which division is the operation required. So, whenever we see each in a problem, we can expect that division is the most appropriate operation to solve that problem. So we are at the end of practice paper 3A, and Jerry Lewis is jumping and shouting and clapping himself because he has pointed out a few things to me in order that my presentation may be smooth.